Hello there, and welcome to the Sleepy Science Journey. I'm so glad you found your way here tonight. Perhaps the day has been long. Perhaps your mind has been racing. Perhaps you simply need a quiet moment to let the world fall away. Either way, this video is for you. Let your shoulders release their tension. Let your breath deepen and slow. Let your thoughts grow lighter, as if they're drifting away on a gentle current. Tonight, we turn our eyes to the heavens, to the vast and peaceful cosmos that surrounds us. We'll explore the most calming, soothing facts about the universe, from the silence of space itself to the ancient light that has traveled across billions of years to reach your eyes, from the rhythmic dance of planets to the patient cycles of stars being born and dying in quiet majesty. Some of what you hear may surprise you. Some may simply spark a gentle sense of wonder as you drift towards sleep. And if these calm explorations bring you peace, consider liking and subscribing. It helps others find their way here too, one sleepy soul at a time. But for now, let's begin our journey through the serene wonders of the cosmos. The universe is silent, not the kind of silence you experience in a quiet room, where you might still hear the hum of electronics or the distant murmur of the world outside. No, the silence of space is something far more profound. It is absolute. In the vast reaches between the stars, there is no sound at all, not a whisper, not a breath, nothing. Sound, as we understand it here on Earth, needs something to travel through. It moves as a wave, a vibration that passes from one molecule to another, rippling outward like the circles that spread when you drop a stone into still water. When you speak, your vocal cords vibrate and shake the air around them. Those vibrations spread out, bouncing from air molecule to air molecule, until they reach someone's ear and their brain interprets the pattern as words, as music, as laughter or song. But in space, there is no air. There are no molecules densely packed enough to carry these vibrations from place to place. Space is a vacuum, a vast emptiness where matter is spread so thin that sound simply cannot exist. If you could somehow survive in the void between the stars, you could scream as loudly as you possibly could, and no one would hear you. Not because the sound would be too quiet, but because there would be no sound at all. The vibrations would begin at your throat, and then they would simply stop, unable to travel any farther. They would go nowhere. They would fade into the emptiness like ripples trying to spread across a pond that has no water. This silence is not a flaw or an absence. It is simply the nature of space itself. And there is something remarkably peaceful about that thought. In a world where we are constantly surrounded by noise, where the air is filled with the buzz of traffic, the chatter of conversations, the endless hum of modern life, space offers something different. It offers a place where all of that falls away, a place of perfect, unbroken quiet. Of course, this silence is not entirely complete. While the vast majority of space is indeed a vacuum, there are pockets, small regions, where gas and dust gather in clouds dense enough that sound could, in theory, exist. In the swirling clouds of a nebula, where new stars are beginning to form, or in the hot plasma surrounding a black hole, the particles are close enough together that pressure waves, the essence of sound, can move from one to another. But even there, the sound would be so deep, so far below the range of human hearing, that we would never be able to detect it with our ears alone. It would be a rumble felt rather than heard, a vibration at the very edge of perception. Scientists have, in recent years, found ways to translate some of these cosmic vibrations into sounds that we can hear. In 2022, NASA released a recording of what a black hole in the Perseus galaxy cluster might sound like. The black hole, sitting some 250 million light years away from Earth, creates ripples in the plasma around it. These ripples are sound waves, but they are incredibly low in frequency, 57 octaves below middle C on a piano. That's so low that no human ear could ever detect it naturally. But by raising the pitch, by shifting those deep vibrations into a range we can hear, scientists created something haunting and eerie, a cosmic hum, a growl echoing through the void. Still, these are exceptions, small islands of near sound in an ocean of silence. The overwhelming majority of space remains utterly quiet. And that quiet is something to marvel at. It is a reminder that the universe, for all its energy, for all its light and motion and grandeur, exists in a state of deep and perfect stillness. There is no cacophony of sound echoing through the cosmos. There is only the silence, vast and serene, stretching on forever. Imagine that silence for a moment. Imagine floating in space, suspended in the endless dark, with no ground beneath you, no sky above. Nothing but the stars scattered like distant lanterns in every direction. You cannot hear your own breathing because there is no air to carry the sound. You cannot hear the beating of your heart. You cannot hear anything. The only thing you would experience is stillness, a stillness so complete it feels almost sacred. This silence is not empty. It is not lonely. It is simply there, a presence in itself, as fundamental to the nature of the universe as the stars and the galaxies and the planets that move through it. It is a silence that has existed for billions of years, long before the first human ear ever evolved to hear sound. It is a silence that will continue long after all the sounds of Earth have faded away. And there is peace in that. There is comfort in knowing that somewhere out there, beyond the noise and chaos of our everyday lives, there exists a place where everything is still, where the universe simply is, quiet and patient, untroubled by the need to announce its presence. It does not shout. It does not demand attention. It simply exists in silence, waiting for us to notice. The stars above us shine with a light that is ancient beyond measure. When you step outside on a clear night and look up at the sky, you are not seeing the stars as they are now. You are seeing them as they were, sometimes thousands, sometimes millions, sometimes even billions of years ago. The light from those stars has been traveling through space for an unimaginable length of time, crossing the vast distances between us and them at a speed so great that it defies ordinary comprehension. And yet, even at that speed, the journey is so long that by the time the light reaches your eyes, the star that emitted it may have changed. It may have grown older. It may have died. It may no longer even exist. Light travels at just under 300,000 kilometers per second. That is fast enough to circle the Earth more than 7 times in a single second. Fast enough to travel from the Earth to the Moon in just over a second. But the universe is so vast that even this incredible speed is not enough to make the journey instantaneous. The closest star to our Sun, Proxima Centauri, is about 4.2 light years away. That means the light we see from it tonight left that star more than 4 years ago. It has been traveling through the void all that time, crossing the emptiness between us, finally arriving now to twinkle in our night sky. But Proxima Centauri is practically on our doorstep compared to some of the other stars we can see. The bright star Sirius, visible in the winter sky, is about 8.6 light years away. The light we see from Sirius left that star when the year was 2016. Betelgeuse, the red giant in the constellation Orion, is roughly 600 light years away. The light from Betelgeuse that reaches your eyes tonight began its journey around the year 1400. When that light left the star, the Renaissance was still a distant dream. The printing press had not yet been invented. The world was a different place. And those are relatively nearby stars. There are stars in our own galaxy that are tens of thousands of light years away. The light from those stars has been traveling since before humans existed, since before our ancestors walked the earth, since before our species even began. It has crossed the spiral arms of the Milky Way, moving through clouds of gas and dust, past other stars, past planets and asteroids, and all the invisible matter that fills the space between. When we look beyond our own galaxy, the distances become even more staggering. The Andromeda Galaxy, our nearest large galactic neighbor, is about 2.5 million light years away. The light we see from Andromeda tonight left that galaxy 2.5 million years ago, long before the first humans appeared. It has been traveling through the intergalactic void ever since, moving through a darkness so vast that it contains almost nothing. No stars, no planets, just the occasional atom drifting alone in the emptiness. There are galaxies so far away that the light from them has been traveling for billions of years. We see them not as they are, but as they were when the universe was young, when the first stars were just beginning to form, when the great structures of galaxies and galaxy clusters were only starting to take shape. That light has crossed a distance so vast that the mind struggles to grasp it. It has journeyed through time as well as space, carrying with it a message from the distant past, a glimpse of a universe that no longer exists in the form we see. And all of this happens silently. The light does not announce its arrival. It does not need to. It simply comes, patient and steady, moving through the darkness, crossing the years and the light years, until finally, after all that time, it reaches us. It enters our telescopes. It falls upon our eyes. And for a brief moment, we see what was. We touch the past. We connect with something far beyond ourselves. There is something deeply calming about this. It reminds us that the universe operates on scales far greater than our own. The light that reaches us tonight has been traveling for longer than we have been alive, longer than our civilization has existed, longer, in many cases, than our entire species has walked the earth. It has crossed distances so vast that they dwarf anything we can experience in our daily lives. And yet, it arrives gently, quietly, asking nothing, simply offering itself to be seen. When you look up at the stars, you are not just looking at distant suns. You are looking back through time. You are seeing the universe as it was, layer upon layer of history written in light. And that light, ancient and patient, has traveled unimaginable distances to reach you. It has crossed the void, undeterred by the vastness, untroubled by the emptiness, simply moving forward, always forward, until at last it arrives here, now, in this moment, shining softly above you as you rest. Stars are born in clouds, not the fluffy white clouds that drift across our daytime sky, but clouds of an entirely different kind, nebulae, vast sprawling regions of space filled with gas and dust, so large that they can be hundreds of light years across. Within these clouds, where the density of matter is greater than the surrounding void, gravity begins to work its slow, patient magic. Gravity is the gentlest of the fundamental forces, the weakest by far, and yet it is also the most patient. It does not rush. It does not demand. It simply pulls quietly and persistently, drawing particles together, coaxing them closer over millions of years. In a nebula, this process begins on a scale almost too small to notice. A few atoms drift together, then a few more. Slowly, so slowly that no eye could ever see the change, a clump begins to form. The clump grows, pulling in more gas, more dust, its gravity increasing as its mass increases. Over time, the clump becomes denser. The particles within it begin to heat up as they are compressed. As gravity squeezes them tighter and tighter, the temperature rises, the pressure builds, and eventually, after millions of years of this slow, steady accumulation, something remarkable happens. The core of the clump becomes hot enough, dense enough, that the atoms within it begin to fuse. Hydrogen atoms smash together, their nuclei combining to form helium, releasing tremendous amounts of energy in the process. And in that moment, a star is born. It is not a sudden event. There is no explosion, no dramatic flash of light. It is a transition, a crossing of a threshold. One moment, there is a clump of hot gas. The next, there is a star, glowing with the light of nuclear fusion, beginning its long, stable life as it burns its way through the hydrogen in its core. This process, this quiet transformation from cloud to star, is happening all across the universe. In the great nebulae like the Orion Nebula, visible to the naked eye as a faint smudge in the constellation of Orion, stars are being born even now. Within the swirling clouds of gas and dust, gravity is at work, pulling matter together, creating the next generation of suns. Some of these stars will be small, dim, burning their fuel slowly and steadily for trillions of years. Others will be massive, bright, burning fiercely and living fast, destined to end their lives in spectacular explosions. But all of them begin the same way. All of them start as a cloud, a gentle gathering of matter, a slow collapse under the patient pull of gravity. There is something profoundly peaceful about this image. The idea that stars are not made in violence or chaos, but in patience, that they are born from clouds, from the slow, steady work of gravity pulling particles together over unimaginable stretches of time. There is no rush, there is no urgency. There is only the gradual, inevitable gathering, the quiet transformation of gas and dust into light and heat and life. And the nebulae themselves are beautiful. When we look at images of places like the Eagle Nebula, with its towering pillars of gas and dust, or the Carina Nebula, glowing with the light of newly formed stars, we see not just the birthplaces of suns, but works of art on a cosmic scale. The colors, the shapes, the intricate structures carved by stellar winds and radiation, all of it speaks to the delicate balance of forces at work. Gravity pulling inward, pressure pushing outward, light and heat sculpting the clouds into forms that seem almost too beautiful to be real. These nebulae are not empty voids. They are active, dynamic regions filled with the raw materials of creation. Within them, the cycle of star formation continues, generation after generation. Old stars die, scattering their enriched matter back into space. That matter mixes with the existing clouds, adding heavier elements, the carbon and oxygen and iron that were forged in the cores of previous stars. And from those enriched clouds, new stars form, carrying with them the legacy of the stars that came before. This cycle has been going on for billions of years. It will continue for billions more. It is a rhythm, a pattern, a cosmic dance that plays out across the universe, unhurried and eternal. Stars are born, stars live, stars die, and from their remnants, new stars are born again. It is a process that requires no observer, no intervention. It simply happens, quietly and patiently, as it always has. And in that patience, there is peace. The universe is not in a hurry. It does not need to be. It has time, all the time in the world, all the time in the universe. And so it takes its time, allowing stars to form slowly, allowing them to live out their lives at their own pace, allowing the great cycle of creation and destruction to unfold in its own gentle, unhurried way. Once a star is born, it enters the longest and most stable phase of its life. This is called the main sequence. During this time, the star burns hydrogen in its core, fusing it into helium and releasing energy in the form of light and heat. It is a process that can last for millions, billions, even trillions of years, depending on the mass of the star. And throughout all that time, the star remains in balance, a delicate equilibrium between two opposing forces. On one side is gravity, pulling inward, trying to crush the star down into an ever smaller, ever denser point. On the other side is the pressure from the nuclear fusion in the core, pushing outward, resisting the collapse. These two forces are perfectly matched. The outward pressure exactly balances the inward pull of gravity. And as long as this balance holds, the star remains stable. It shines steadily. It does not grow. It does not shrink. It simply is, a glowing sphere of plasma, floating in the void, radiating light and heat into the surrounding space. Our sun is a main sequence star. It has been shining steadily for about 4.6 billion years, and it will continue to shine for another 5 billion years or so before it begins to change. That is a long time, longer than the Earth has existed, longer than life has been on our planet, longer than we can truly comprehend. And throughout all that time, the sun has been remarkably consistent. Its brightness has varied only slightly. Its temperature has remained stable. It has provided a steady source of energy for the Earth, allowing life to evolve and thrive. This stability is one of the most remarkable things about stars. They are not chaotic or unpredictable. They do not flicker and sputter. They burn with a calm, steady glow, maintained by the perfect balance of forces within them. Day after day, year after year, century after century, millennium after millennium, they shine. And in that shining, there is a kind of constancy, a reliability that is deeply reassuring. The stars you see in the night sky have been shining for a long time. Many of them have been there, in more or less the same place, for all of human history. The ancient Egyptians looked up at the same stars we see now. The ancient Greeks, the ancient Chinese, the people who built Stonehenge, all of them saw the same constellations, the same patterns of light in the darkness. The stars have been there, steady and unchanging, for as long as humans have been around to notice them. Of course, this is not entirely true. Stars do change. They evolve. They age. But they do so on timescales so vast that from our perspective, they might as well be eternal. A star like the sun changes so slowly that a human lifetime is far too short to notice any difference. Even over the span of recorded human history, the changes in most stars are too subtle to detect without precise instruments. They simply shine as they have always shone, as they will continue to shine for ages to come. There is comfort in this, in a world that is constantly changing, where nothing seems to stay the same. The stars offer a kind of permanence. They are a reminder that some things endure, that some things are stable, that the universe, for all its vastness and mystery, contains elements of constancy and peace. And the stars themselves are content. They do not struggle. They do not strive. They simply burn, converting hydrogen into helium, releasing energy, shining their light into the void. They do not need to do anything else. They do not need to justify their existence or prove their worth. They simply are, and in being, they fulfill their purpose. They light the darkness. They warm the space around them. They create the elements that will one day form planets and, perhaps, life. There is a lesson in that, if we choose to see it. A lesson about balance, about patience, about the value of simply being rather than constantly doing. The stars do not rush. They do not hurry. They take their time, burning their fuel at a steady, sustainable rate, shining for billions of years because they are in no rush to burn out. They are a model of endurance, of stability, of quiet, persistent presence. And when we look up at them, we can feel that presence. We can see the light that has been shining for so long, crossing the distances to reach us, steady and calm. And perhaps, for a moment, we can let some of that calm settle over us. We can let the constancy of the stars remind us that not everything is in flux, that some things endure, that the universe, in its own way, is patient and stable and at peace. Stars do not last forever. Even the longest-lived stars, the small red dwarfs that burn their fuel so slowly they could shine for trillions of years, will eventually run out. And when a star runs out of fuel, when the hydrogen in its core is exhausted, it must face the end. But this end is not violent, not for stars like our sun. For them, the end is a transformation, a shedding of their outer layers, a slow and graceful fading into the dark. As a star like the sun ages, it begins to run low on hydrogen in its core. The fusion reactions that have sustained it for billions of years start to slow. And when they slow, the outward pressure they create begins to drop. Gravity, no longer balanced, starts to win. The core begins to collapse, heating up as it shrinks. And that heat radiating outward causes the outer layers of the star to expand. The star swells. It grows larger, cooler, redder. It becomes a red giant, a bloated, luminous sphere that can grow to be hundreds of times its original size. If the sun were to become a red giant today, it would expand so much that it might swallow the inner planets, including Earth. But this expansion is not a sudden event. It happens slowly over millions of years, a gradual swelling as the star adjusts to the changing conditions in its core. Eventually, even the red giant phase cannot last. The star continues to lose mass, shedding its outer layers into space. These layers drift away, forming a glowing shell of gas around the dying star. This shell is called a planetary nebula, though it has nothing to do with planets. It was named long ago, when astronomers looking through early telescopes thought these glowing shells looked a bit like the disks of planets. Today, we know they are something far more beautiful. They are the final breath of a star, a last exhalation of matter into the surrounding space. At the center of the planetary nebula, the core of the star remains. It is no longer large enough or hot enough to sustain fusion. It has collapsed down into a dense, hot ember, a white dwarf about the size of the Earth, but with a mass comparable to the Sun. This white dwarf glows with the leftover heat from its previous life, radiating light into space, even though it is no longer actively generating energy through fusion. Over time, over billions of years, it will cool, it will fade. Eventually, it will become a cold, dark cinder, a black dwarf drifting silently through space, a relic of what it once was. This is the fate of our Sun. In about 5 billion years, it will begin its transformation into a red giant, and then, eventually, it will shed its outer layers and become a white dwarf, slowly cooling over eons until it finally goes dark. But there is no violence in this process, no explosion, no dramatic end, just a slow, quiet fading, a gentle return to the darkness from which all stars ultimately came. And the material that the star sheds, the gas and dust that forms the planetary nebula, does not simply disappear. It drifts out into space, mixing with the interstellar medium, the thin soup of gas and dust that fills the space between the stars. And from that material, enriched now with heavier elements forged in the star's core, new stars will eventually form. The cycle continues. The matter that once made up a star becomes part of a new cloud, a new nebula, and eventually a new star. And in this way, stars are not truly destroyed. They are transformed. They are recycled. They return to the cosmos, their matter joining the great river of creation that flows through the universe. There is something deeply peaceful about this cycle. It is a reminder that nothing is ever truly lost, that every ending is also a beginning, that the matter that makes up the stars and the planets and even us is constantly being reused, reshaped, reformed. We are, in a very real sense, made of stardust. The atoms in our bodies were forged in the cores of stars that lived and died long before the sun even existed. Those stars ended their lives, shed their outer layers, and scattered their enriched matter into space. And from that matter, new stars and planets formed, including our sun and our Earth. And on that Earth, those atoms came together to form life. So when we look at a planetary nebula, we are not just seeing the death of a star. We are seeing the continuation of a cycle that has been going on for billions of years. We are seeing the universe in the process of renewing itself, taking the old and making it new, transforming what was into what will be. And in that transformation, there is no sadness. There is only change. And change in the universe is neither good nor bad. It simply is. It is the nature of things. It is the way the cosmos works. And knowing this, we can look at the end of a star and see not a tragedy, but a transition, not a loss, but a continuation. The star does not disappear. It becomes something else. And in becoming something else, it contributes to the ongoing story of the universe, a story that has no end, only endless transformations, endless cycles, endless rebirth. The universe is expanding. This is one of the most profound discoveries in the history of science, and yet it is also one of the most calming. The space between galaxies is growing. Every moment, the distance between distant clusters of galaxies increases, and this expansion is not the result of galaxies flying through space, moving away from each other like shrapnel from an explosion. Rather, it is space itself that is expanding, stretching like a rubber sheet being pulled in all directions at once. This expansion was first discovered in the late 1920s when the astronomer Edwin Hubble observed that distant galaxies were moving away from us. And not just moving, but moving in a very specific way. The farther away a galaxy was, the faster it seemed to be receding. This relationship, now known as Hubble's law, provided the first clear evidence that the universe was not static, but dynamic, growing larger with time. Since then, our understanding of this expansion has deepened. We now know that the expansion began with the Big Bang, the event that marked the beginning of the universe itself, some 13.8 billion years ago. In the first moments after the Big Bang, the universe was incredibly hot and incredibly dense, and it expanded at an unimaginable rate. Over time, as the universe cooled and matter began to clump together, the expansion slowed, held back by the gravitational attraction of all the matter in the universe. But then, something unexpected happened. Around 9 billion years after the Big Bang, the expansion of the universe began to speed up again. Instead of slowing down, as gravity would suggest, the expansion started to accelerate. This acceleration is driven by something we call dark energy, a mysterious force that makes up about 68% of the total energy content of the universe. We do not fully understand what dark energy is or how it works, but we can see its effects. It is pushing space apart, causing the expansion to speed up, and it appears to be getting stronger as the universe grows larger. This might sound alarming. The idea that the universe is expanding faster and faster might seem like it should be a cause for concern. But in truth, the expansion is gentle. It is not a violent tearing apart of space, but a slow, steady stretching. On small scales, like the scale of our solar system or even our galaxy, the expansion is completely negligible. Gravity holds these structures together far more strongly than the expansion can pull them apart. The Earth is not moving away from the Sun. The solar system is not spreading out. The Milky Way galaxy is not being torn to pieces. It is only on the largest scales, the scales of galaxy clusters and superclusters, that the expansion becomes noticeable. And even there, it is a slow process. Galaxies that are not gravitationally bound to each other, that are not part of the same cluster, are slowly drifting apart. The space between them is growing, but this growth happens gradually, over billions of years. It is not something that would ever be perceptible in a human lifetime. It is a cosmic process unfolding on cosmic timescales. And there is something strangely calming about that. The universe is not rushing anywhere. It is not hurrying towards some dramatic end. It is simply expanding, slowly and steadily, at a pace that is almost too gentle to notice, unless you are looking at the very largest scales. The galaxies are drifting apart, yes, but they are doing so with no urgency, no haste. They are simply following the natural flow of space, moving along with the expansion carried by the gentle current of the cosmos. In a way, the expansion of the universe is like a long, slow exhalation. The universe is breathing out, stretching itself, growing larger, and in that growth, there is no tension, there is no strain, there is only the smooth, gradual unfolding of space, the quiet increase in distance, the peaceful drift of galaxies as they move with the flow. Scientists are still studying the expansion, trying to understand exactly how it works, what dark energy is, and what the ultimate fate of the universe might be. Will the expansion continue forever, with galaxies drifting farther and farther apart until the universe becomes a cold, dark, empty place? Or will something else happen? Some change we do not yet understand. We do not know. But whatever the answer, it is clear that the universe is not in any hurry to get there. It has time, all the time in the world, all the time in the universe. And so it expands gently and patiently at its own pace, content to let the future unfold in its own way. Planets do not race around their stars. They do not hurtle chaotically through space. Instead, they move in smooth, regular orbits, following paths that are as predictable as they are ancient. The motion of a planet is governed by gravity, the same force that holds it to its star and keeps it from flying off into the void. And that motion, that slow, rhythmic dance, has continued for billions of years, unchanged and unchanging. Our own solar system is a perfect example. The Earth orbits the Sun once every 365 days. Mars takes 687 days. Jupiter takes nearly 12 years. These are not random numbers. They are the result of the delicate balance between the planet's speed and the Sun's gravitational pull. Each planet moves at just the right speed to stay in its orbit, neither falling into the Sun nor drifting away into space. It is a balance that has held for over 4.5 billion years, ever since the solar system first formed. And the orbits themselves are not perfect circles. They are ellipses, slightly elongated circles, with the Sun at one focus. This means that a planet's distance from the Sun changes as it moves along its orbit. At some points, it is closer. At others, it is farther away. But even this variation follows a predictable pattern. When a planet is closer to the Sun, it moves faster. When it is farther away, it moves slower. This is because of the conservation of angular momentum, a fundamental principle of physics that ensures that the planet's motion remains smooth and regular. These orbital motions are described by Kepler's laws of planetary motion, discovered in the early 1600s by the astronomer Johannes Kepler. Kepler found that planets move in elliptical orbits, that they sweep out equal areas in equal times as they orbit, and that there is a mathematical relationship between the size of a planet's orbit and the time it takes to complete one orbit. These laws are beautifully simple, and they describe the motion of planets with remarkable precision. They work not just for the planets in our solar system, but for planets orbiting other stars as well, for moons orbiting planets, for any object moving under the influence of gravity. And there is something profoundly calming about this regularity. The planets do not waver. They do not stray from their paths. They simply move day after day, year after year, eon after eon, following the same orbits they have always followed. The Earth will be in the same place in its orbit next year at this time as it is now. Mars will return to the same point in its orbit every 687 days. Jupiter will complete its slow circuit of the Sun every 12 years, just as it has for billions of years. This predictability is a source of stability. It is why we can calculate the positions of the planets with such accuracy, why we can predict eclipses centuries in advance, why we can send spacecraft to distant worlds and know exactly where those worlds will be when the spacecraft arrives. The motion of the planets is not chaotic. It is ordered. It is harmonious. It is a cosmic clockwork, ticking away with perfect regularity. And in some planetary systems, This harmony is even more pronounced. Astronomers have discovered systems where the planets are locked in what is called orbital resonance. In these systems, the orbital periods of the planets have simple mathematical relationships with each other. For every 2 orbits one planet makes, another might make exactly 3. For every 4 orbits one makes, another makes exactly 6. These resonances create a kind of musical rhythm, a cosmic symphony where the planets move in time with each other, their motions synchronized in a way that is almost too perfect to be a coincidence. One such system is Towai 178, a star located about 200 light-years away. This system has 6 planets, 5 of which are locked in a resonant chain. Their orbital periods follow the ratio 18:9 to 6:4 to 3. This means that for every 18 orbits the outermost planet makes, the next one in makes 9, the next makes 6, and so on. It is a pattern that repeats with perfect regularity, a rhythm that has been maintained for millions, perhaps billions of years. Scientists believe that such resonances are a sign of a calm, stable formation process. The planets in these systems likely formed in a disk of gas and dust around the star, and as they grew, their gravitational interactions with each other and with the disk caused their orbits to settle into these resonant patterns. It is a kind of self-organization, a natural tendency toward harmony and balance. And there is something beautiful about that. The idea that the universe, left to its own devices, tends toward order, that planets, given enough time, will find their rhythms and settle into them, that the cosmos is not a place of chaos, but a place of patterns, of regularities, of harmonies that emerge from the simple laws of physics. When we think about the planets moving in their orbits, we can picture them as dancers, each following their own path, but all moving to the same underlying beat. They do not collide. They do not interfere with each other. They simply move, each in their own lane, each at their own pace, all part of the same grand dance that has been going on for billions of years. And in that dance, there is peace, there is order, there is a sense that everything is as it should be, that the planets are where they belong, moving as they were meant to move, following paths that were laid down at the beginning of time. The universe operates on scales of time that are difficult for the human mind to fully grasp. We measure our lives in years, in decades. A human lifetime on average is around 70 to 80 years. That seems like a long time to us. It is all the time we have. But in the context of the universe, it is almost nothing. It is a blink, a single beat of a cosmic heart. Less than an instant. To help put this in perspective, scientists sometimes use a tool called the cosmic calendar. This is a way of compressing the entire history of the universe, all 13.8 billion years of it, into a single year. January 1st at midnight is the Big Bang. December 31st at just before midnight is the present day. Every month on this calendar represents a little over a billion years. Every day represents about 38 million years. Every second represents about 438 years. On this cosmic calendar, the Milky Way galaxy begins to form in late spring, around May. The Sun and the solar system appear in early September. The first life on Earth shows up in late September. But complex life, the kind of life we can see without a microscope, does not appear until mid-December. Dinosaurs show up on December 25th and go extinct on December 30. And humans, modern humans, Homo sapiens, do not appear until the very last moments of the year. We show up at around 11:52 p.m. on December 31st. All of recorded human history, everything from the ancient Egyptians to the present day, occupies the last 10 seconds of the year. Think about that for a moment. All of human civilization, all of our history, all of our art and science and culture, everything we have ever built or discovered or created, fits into the last 10 seconds of a year that represents the entire history of the universe. We are newcomers. We are latecomers. We have only just arrived. And an individual human life. On the cosmic calendar, a human lifetime of 75 years is about 0.17 seconds, less than the time it takes to blink. You are born, you live, you die, all in less than a heartbeat of cosmic time. This might seem depressing at first. It might seem to diminish the importance of our lives, to make us feel small and insignificant. But there is another way to look at it. There is a kind of peace in realizing just how brief our time is in the grand scheme of things. It reminds us that the things we worry about, the stresses and anxieties of our daily lives, are fleeting. They are temporary. They are a tiny blip in the vast expanse of time. The universe has been around for 13.8 billion years. It will likely continue for trillions more. The stars will keep shining. The galaxies will keep drifting. The cosmos will keep doing what it has always done, utterly indifferent to our concerns, our ambitions, our fears. And in that indifference, there is freedom. There is permission to let go, to stop worrying so much about the small things, to recognize that in the end, we are all just passing through. Our lives a brief flicker in the long, slow unfolding of cosmic time. This is not to say that our lives do not matter. Of course they matter. They matter to us. They matter to the people we love, but they do not matter to the universe. And there is a strange comfort in that. It means we do not have to carry the weight of the world on our shoulders. We do not have to solve every problem, fix every mistake, achieve every goal. We can simply be. We can live our brief lives as best we can, knowing that we are part of something much larger, something that existed long before us and will continue long after we are gone. And in that knowledge, we can find peace. We can let go of the need to control everything, to understand everything, to make sense of everything. We can accept that we are small, that our time is short, that we are just one tiny part of an unimaginably vast and ancient cosmos. And in accepting that, we can relax, we can breathe, we can let the universe be what it is, and let ourselves be what we are, without needing it to be anything more. The universe is held together by forces we cannot see. Four fundamental forces govern all of reality, shaping everything from the smallest particles to the largest structures in the cosmos. These forces are gravity, electromagnetism, the strong nuclear force, and the weak nuclear force. And together, they create a kind of cosmic balance, a harmony that allows the universe to exist as it does. Gravity is the force we are most familiar with. It is what keeps our feet on the ground, what holds the Earth in orbit around the Sun, what binds galaxies together and shapes the large-scale structure of the universe. Gravity is the weakest of the four fundamental forces, but it has the longest range. It works across infinite distances, always attractive, always pulling matter together. And because of this, gravity is responsible for the formation of planets, stars, galaxies, and all the grand structures we see in the cosmos. Electromagnetism is the force that governs the interactions between charged particles. It is what holds atoms together, what allows molecules to form, what makes chemistry possible. It is also the force behind light. Light is an electromagnetic wave, a ripple in the electromagnetic field, traveling through space at the ultimate speed limit of the universe. Without electromagnetism, there would be no atoms, no molecules, no chemical reactions, no light. There would be no stars shining, no planets with atmospheres, no life. The strong nuclear force is the force that binds protons and neutrons together in the nucleus of an atom. It is incredibly strong, but it only works over very short distances about the size of an atomic nucleus. Without the strong force, atomic nuclei would not exist. Protons, which are positively charged, would repel each other due to electromagnetism, and atoms would simply fall apart. The strong force overcomes this repulsion, holding the nucleus together and allowing the elements to exist. The weak nuclear force is responsible for certain types of radioactive decay. It is weaker than the strong force and electromagnetism, but stronger than gravity. It plays a crucial role in the processes that power the sun. In the core of the sun, the weak force allows protons to convert into neutrons, a step in the fusion process that turns hydrogen into helium and releases the energy that makes the sun shine. Without the weak force, the sun would not shine, and life on Earth would not be possible. These four forces work together to create the universe as we know it. Gravity pulls matter together into stars and galaxies. Electromagnetism allows atoms and molecules to form, creating the building blocks of chemistry and life. The strong force holds atomic nuclei together, allowing the elements to exist. And the weak force powers the nuclear reactions in stars, providing the energy that lights up the cosmos. And there is a remarkable balance in all of this. If any of these forces were slightly different, if gravity were a bit stronger or electromagnetism a bit weaker, the universe would look very different. Stars might not be able to form. Atoms might not be stable. The delicate conditions that allow for the existence of planets and life might not be possible. But the forces are exactly as they are, finely tuned in a way that allows the universe to be rich and complex and full of structure. This balance is not something we fully understand. It is one of the deep mysteries of physics. Why are the forces the strengths they are? Why do they have the properties they have? We do not know. But we can observe the results. We can see the harmony that these forces create, the way they work together to shape reality, to build atoms and stars and galaxies, to make the universe a place where interesting things can happen. And in that harmony, there is a kind of cosmic peace. The forces do not fight each other. They do not struggle for dominance. They simply are, each doing what it does, each playing its role in the grand symphony of existence. Gravity pulls, electromagnetism binds, the strong force holds, the weak force transforms, and together they create a universe that is stable, ordered, beautiful. When we look at the night sky, we are seeing the result of these forces at work. The light from the stars is electromagnetic radiation, traveling through space at the speed of light. The stars themselves shine because of the weak force, which allows fusion to occur in their cores. They hold together because of the strong force, which binds their atoms, and because of gravity, which pulls their mass inward. And all of this happens in a delicate balance. a harmony of forces that has been maintained for billions of years. There is comfort in knowing that the universe is not chaos, that it is governed by laws, by forces, by principles that are consistent and predictable, that the same laws that govern the motion of a falling apple also govern the motion of the planets and the stars, that the universe is, at its core, a place of order and balance where forces work in harmony to create the rich and varied cosmos we see around us. And in that order, in that balance, we can find peace. We can let go of the need to control, to understand, to make sense of everything all at once. We can trust that the universe knows what it is doing, that the forces are working as they should, that everything is unfolding according to the laws of nature. And in that trust, we can relax, we can rest, we can allow ourselves to simply be part of this vast, balanced, harmonious whole. The universe is not just vast in space, it is also ancient in time, 13.8 billion years. That is the current estimate for the age of the universe, the time that has passed since the Big Bang, the moment when space and time and matter and energy all came into existence. 13.8 billion years of expansion, of cooling, of matter clumping together and forming the first stars, the first galaxies, the first planets. It is almost impossible to comprehend a span of time that long. 13.8 billion years. How do we even begin to wrap our minds around such a number? Let us try to break it down. 1,000,000 years is a long time. It is longer than human civilization has existed, longer than our species has been on Earth. 1,000,000 years ago, our ancestors were still evolving, still learning to use tools, still figuring out how to survive in a world very different from the one we know today. Now multiply that by 1,000. 1,000,000,000 years. 1,000,000,000 years is 1,000,000,000 years. It is so long that entire species have come and gone. Continents have drifted across the face of the Earth. The climate has changed beyond recognition. 1,000,000,000 years ago, life on Earth was still relatively simple. There were no plants, no animals, just single-celled organisms, bacteria and algae, drifting in the oceans. And the universe is not just 1 billion years old. It is 13.8 billion years old, almost 14 billion years. That is 13 times longer than the age of complex life on Earth. It is more than 3 times longer than the age of the Earth itself. It is a span of time so vast that it dwarfs anything we can relate to in our daily lives. And throughout all that time, the universe has been changing. It began as a hot, dense point, smaller than an atom, and it has been expanding ever since. In the first moments after the Big Bang, the universe was unimaginably hot and dense. There were no atoms, no particles as we know them, just a seething soup of energy and fundamental particles expanding and cooling rapidly. As the universe expanded, it cooled. And as it cooled, particles began to stick together. Protons and neutrons formed. Then, about 380,000 years after the Big Bang, the universe had cooled enough for electrons to bind to protons, forming the first atoms of hydrogen and helium. This moment is called recombination, and it marked a major turning point in the history of the universe. Before recombination, the universe was opaque. Photons, particles of light, could not travel far before being absorbed or scattered by the dense plasma of free electrons. But after recombination, the universe became transparent. Light could suddenly travel freely through space, and that light is still traveling today. We can see it in the form of the cosmic microwave background, the faint glow of radiation that fills the entire sky, a relic of the hot, dense state of the early universe. For hundreds of millions of years after recombination, the universe was dark. There were no stars, no galaxies, just vast clouds of hydrogen and helium drifting through space, slowly clumping together under the pull of gravity. This period is called the Dark Ages of the universe, and it lasted for about 400 million years. Then, around 400 million years after the Big Bang, the first stars began to form. These were massive, bright stars, formed from the primordial hydrogen and helium that filled the universe. They lived fast and died young, ending their lives in spectacular supernova explosions that scattered the first heavy elements into space. And from those enriched clouds, new generations of stars formed, each one carrying the legacy of the stars that came before. Over billions of years, the universe continued to evolve. Galaxies formed, grew, merged with each other. Clusters of galaxies came together, creating the large-scale structure we see today, the cosmic web of galaxies and voids that stretches across the observable universe. And all the while, stars were born and died, planets formed, and the universe became richer and more complex. And here we are, 13.8 billion years later, living on a planet orbiting a star in a galaxy that is just one of hundreds of billions of galaxies in the observable universe. We are latecomers to this story. The universe existed for over 9 billion years before the Sun even formed. It existed for over 13 billion years before the first humans appeared. We have only been here for a tiny fraction of cosmic time, a brief moment in a story that has been unfolding for eons. But what a story it is. A story of transformation, of change, of the universe evolving from a hot, dense state into the rich, complex cosmos we see around us. A story of stars forming and dying, of galaxies colliding, of planets being born. A story that is still being written, still unfolding, even now. And in that story, we can find a kind of peace. We can see that we are part of something much larger than ourselves, something that has been going on for an unimaginable length of time and will continue long after we are gone. We can see that the universe is patient, that it takes its time, that it does not rush. It has been evolving for 13.8 billion years, and it will continue to evolve for trillions more. And in that patience, in that slow, steady unfolding, there is a kind of comfort. The universe is not in a hurry. It does not need to be. It has all the time in the world. The universe is mostly empty. When we look up at the night sky and see the stars scattered across the darkness, it is easy to forget just how much space there is between them. The stars seem close together, like a blanket of light stretched across the sky. But in reality, they are separated by vast, almost unimaginable distances. The nearest star to our Sun, Proxima Centauri, is about 4.2 light years away. That is about 40 trillion kilometers. If you could travel at the speed of light, it would take you over 4 years to get there, and that is the nearest star. Most of the stars we see in the night sky are hundreds or thousands of light years away, and between those stars, there is almost nothing. Space is not truly empty. There are a few atoms scattered here and there, a few molecules, a bit of dust, but the density of matter in interstellar space is incredibly low. In a typical cubic centimeter of space between the stars, there might be only a few atoms. For comparison, the air we breathe contains trillions of atoms in the same volume. This means that the vast majority of the volume of the universe is empty, or nearly empty. There are galaxies, yes, and within those galaxies there are stars and planets and clouds of gas and dust. But most of the universe is the space between the galaxies. And in that space, there is even less matter than in the space between the stars. In the intergalactic voids, the regions of space between galaxy clusters, there might be less than 1 atom per cubic meter. It is almost a perfect vacuum. And yet, this emptiness is not lonely. It is not desolate. It is simply the nature of the universe. Space is, by definition, the absence of things. It is the stage on which matter and energy play out their roles. And that stage is vast, far vaster than the actors themselves. There is something calming about this emptiness. It is a reminder that the universe is not crowded. It is not cluttered. There is room, so much room. More room than we could ever need, more room than we could ever use. The universe is spacious in a way that is hard to comprehend. It is a place where you could travel for billions of years and never encounter anything, where the distances are so great that light itself takes eons to cross them. And in that spaciousness, there is a kind of peace. The universe is not pressing in on us. It is not confining us. It is giving us room to breathe, room to exist, room to be. And knowing that, we can let go of the feeling of being hemmed in, of being trapped, of being confined by the limits of our world. We can remember that we live in a universe that is vast beyond measure, a universe that is mostly empty, a universe where there is always more space, always more room, always more distance to cross. The emptiness of space is also a silence. Without matter to carry sound, there is no noise in the void, just the light moving through the darkness, crossing the immense distances at its own steady pace. The universe is a quiet place, a place where the only sound is the one we bring with us, the hum of our thoughts, the rhythm of our breath. And in that silence, in that emptiness, we can find a kind of stillness. We can let the vastness of space remind us that we do not need to fill every moment with noise, with activity, with something. We can simply be, existing in the quiet, surrounded by the immense, peaceful emptiness of the cosmos. At the heart of every galaxy, there is a secret, a massive black hole, millions or even billions of times the mass of the sun, sitting at the very center, hidden from view, but exerting a powerful influence on everything around it. These supermassive black holes are one of the most mysterious objects in the universe. And yet, in a way, they are also one of the most peaceful. A black hole is a region of space where gravity is so strong that nothing can escape, not even light. The boundary of a black hole is called the event horizon, and once something crosses that boundary, it is gone forever, pulled inexorably inward toward the singularity at the center, where the laws of physics as we know them break down. But despite their fearsome reputation, black holes are not cosmic vacuum cleaners, sucking in everything around them. They are simply very massive objects, and their gravitational pull is no different from the gravitational pull of any other massive object. If the sun was suddenly replaced by a black hole of the same mass, the Earth would continue to orbit exactly as it does now. The gravity would be the same. The only difference would be that the sun would no longer shine. Supermassive black holes, the kind that sit at the centers of galaxies, are even more interesting. They can have masses of millions or billions of times the mass of the sun. and they sit at the very heart of their galaxies, anchoring them, shaping their structure. The Milky Way has a supermassive black hole at its center, called Sagittarius, a star, with a mass of about 4 million times the mass of the Sun. And yet, despite its enormous mass, it is remarkably quiet. For most of their lives, supermassive black holes are dormant. They do not actively feed on matter. They simply sit at the center of their galaxies, exerting their gravitational influence, but otherwise doing very little. Occasionally, if a star or a cloud of gas wanders too close, it can be pulled in, and as it falls toward the black hole, it heats up and emits tremendous amounts of energy. This creates what is called an active galactic nucleus, a bright, energetic region at the center of the galaxy. But most of the time, supermassive black holes are quiet. They are patient. They wait. And in that patience, there is a kind of cosmic calm. Black holes do not rush. They do not need to. They have all the time in the world. They sit at the centers of their galaxies, stable and unchanging, anchors in the cosmic sea. And around them, the galaxy rotates, stars orbit, planets form and die, and the black hole simply remains, a silent, invisible presence at the heart of it all. There is also something deeply peaceful about the idea that black holes are, in a sense, the ultimate recyclers. When matter falls into a black hole, it is not destroyed, it is transformed. It crosses the event horizon and becomes part of the black hole, adding to its mass. And in this way, black holes are the end point of a journey that began with the formation of stars, with the fusion of hydrogen into heavier elements, with the creation of planets and life. Everything that falls into a black hole becomes part of it, part of the strange, dense singularity at the center, and eventually, over unimaginable spans of time, even black holes themselves will evaporate. Through a process called Hawking radiation, black holes slowly lose mass, emitting tiny amounts of energy into space. For a supermassive black hole, this process takes an unimaginably long time, longer than the current age of the universe by many, many orders of magnitude. But eventually, given enough time, even the largest black holes will evaporate, leaving behind nothing but a faint whisper of radiation. So in the end, black holes are not eternal. They are not permanent. They are just another stage in the long, slow cycle of the universe, a stage that lasts for eons, but that will eventually come to an end. And in that, there is a kind of peace. Nothing lasts forever. Not stars, not galaxies, not even black holes. Everything changes, everything transforms, and the universe, patient and unhurried, simply allows it all to happen. We are made of stardust. This is not a metaphor. It is a literal, scientific fact. The atoms that make up our bodies, the carbon and oxygen and nitrogen and iron and all the other elements, were forged in the cores of stars that lived and died long before the sun even existed. We are, in a very real sense, the children of the stars. In the beginning, in the moments after the Big Bang, the universe was filled with only the lightest elements: hydrogen, helium, and tiny amounts of lithium. These were the raw materials of creation, the building blocks from which everything else would be made. But all the heavier elements, everything from carbon to oxygen to iron and beyond, did not exist yet. They had to be made, and the only place they could be made was inside stars. Inside the core of a star, the temperature and pressure are so high that atomic nuclei can fuse together. Hydrogen fuses into helium, releasing energy and keeping the star shining. And in more massive stars, as the hydrogen runs out, helium begins to fuse into carbon and oxygen. And in the most massive stars, the fusion process continues, building heavier and heavier elements, layer upon layer, until the core is made of iron. But iron is the end of the line. Fusing iron does not release energy, it requires energy. And so, when a massive star runs out of fuel and its core becomes iron, it can no longer support itself against the pull of gravity. The core collapses, and in that collapse, the star explodes in a supernova, a blast so powerful that it outshines an entire galaxy for a brief moment. And in that explosion, something remarkable happens. The intense heat and pressure of the supernova create the conditions needed to forge elements heavier than iron. Gold, silver, platinum, uranium, all the heavy elements are created in the heart of a supernova, in a process that lasts only a few seconds, but that produces enough material to seed entire solar systems. The explosion scatters the star's enriched matter into space, and from that matter, new stars and planets form. Our Sun, our solar system, our Earth, all formed from a cloud of gas and dust that was enriched by previous generations of stars. The atoms in our bodies were once part of those stars. The carbon in our cells, the oxygen we breathe, the iron in our blood, all of it was forged in the cores of stars that exploded billions of years ago, scattering their remains into the cosmos. And so, when we look up at the stars, we are not just looking at distant suns. We are looking at our ancestors. We are looking at the places where the atoms that make us were born. We are stardust, condensed and shaped into living, breathing beings, carrying within us the legacy of the stars. There is something profoundly beautiful about this. It connects us to the universe in a deep and fundamental way. We are not separate from the cosmos. We are part of it. We are made of the same stuff as the stars, the same atoms, the same matter. The universe is not something out there, distant and unreachable. It is here, in us, in every breath we take, in every heartbeat, in every thought. And in that connection, there is peace. We are not alone. We are not isolated. We are part of something vast and ancient and ongoing. We are part of the great cycle of creation, the cycle that has been going on for billions of years and will continue for billions more. Stars are born, stars die, and from their ashes, new stars and planets and life emerge. It is a cycle of renewal, a cycle of transformation, a cycle of which we are a part. And knowing this, we can let go of the feeling of being small and insignificant. Yes, we are small compared to the universe, but we are also connected to it. We are made of it. We are stardust, shaped by the cosmos, carrying within us the legacy of stars that burned long before our world even existed. And in that legacy, we can find a sense of belonging, a sense of connection, a sense that we are part of something much larger and much more beautiful than we could ever imagine. Gravity does not just hold planets in orbit or keep our feet on the ground. It also bends light. This is one of the most remarkable predictions of Einstein's theory of general relativity, and it is a prediction that has been confirmed countless times through observation. Gravity, according to Einstein, is not a force in the traditional sense. It is a curvature of space-time itself. Massive objects like stars and planets create a dent in the fabric of space and time, and other objects move along the curves created by that dent. And light, despite having no mass, is also affected by this curvature. When light passes near a massive object, its path bends, following the curve of space-time. This effect is called gravitational lensing, and it has allowed astronomers to observe objects that would otherwise be invisible, to peer into the distant reaches of the universe and see things that would have been hidden from view. Imagine a distant galaxy, so far away that its light is incredibly faint. If there is another, closer galaxy between us and the distant one, the gravity of the closer galaxy can bend the light from the distant galaxy, focusing it and making it brighter, like a giant cosmic magnifying glass. This allows us to see galaxies that are so far away, so dim, that we would never have been able to detect them otherwise. Gravitational lensing has revealed some of the most distant and ancient galaxies in the universe, galaxies that formed when the universe was only a few 100 million years old. It has allowed us to study the distribution of dark matter, the mysterious substance that makes up most of the mass of the universe, but does not emit or absorb light. And it has given us a deeper understanding of the structure and evolution of the cosmos. But beyond its scientific importance, there is something profoundly beautiful about gravitational lensing. It is a reminder that space and time are not fixed, rigid things. They are dynamic, flexible, shaped by the presence of matter and energy. The universe is not a static stage on which events play out. It is an active participant, bending and curving in response to the mass and energy it contains. And there is a kind of cosmic poetry in the idea that light, the fastest thing in the universe, the thing that defines the speed limit of all motion, can be bent by gravity. Light does not travel in straight lines when it passes near a massive object. It curves following the shape of space-time, tracing out paths that are determined by the distribution of mass in the universe. And in that curvature, in that bending of light, we can see the hand of gravity shaping the cosmos. Gravity is not just a force that pulls things together. It is a force that shapes the very fabric of reality, that determines the paths that everything, even light, must follow. And in that shaping, there is a kind of harmony, a kind of balance, a sense that the universe is not chaotic or random, but ordered and structured, governed by laws that are elegant and beautiful. We can find peace in that, in knowing that the universe is governed by principles, by laws, by forces that work in harmony to create the world we see. That light bends because space-time curves, that space-time curves because of mass, that mass comes from matter, and matter comes from the stars. It is all connected. It is all part of the same grand design, the same cosmic order. And when we look up at the night sky and see the light from distant stars, we can know that that light has traveled across vast distances, bent by the gravity of galaxies and stars along the way, shaped by the curvature of space-time, following paths that were determined by the distribution of matter in the universe. And in that knowledge, we can find a sense of wonder, a sense of connection, a sense that we are part of something much larger and much more beautiful than we could ever fully understand. The universe is full of cycles, the cycle of stars being born and dying, the cycle of matter being created in the cores of stars and scattered into space, the cycle of galaxies merging and forming new structures. Everything in the universe is in motion. Everything is changing, and yet these changes follow patterns, rhythms, cycles that have been going on for billions of years. And there is something deeply calming about that. The idea that the universe is not chaotic, not random, but cyclic, that things come and go, that they are born and die, but that the cycle continues. Stars die, but new stars are born from their ashes. Galaxies collide, but new galaxies form. Planets are destroyed, but new planets emerge. The universe is constantly renewing itself, constantly transforming, constantly moving through cycles of creation and destruction. And we, too, are part of these cycles. The atoms in our bodies were once part of stars. They will one day be part of something else. We are temporary, yes, but the matter that makes us is not. It is eternal, or as close to eternal as anything in the universe can be. It will go on, cycling through different forms, different structures, different lives, long after we are gone. And in that, there is comfort. We are not truly lost when we die. We are simply transformed. The atoms that make us will return to the earth, and from the earth, they will eventually be scattered into space, perhaps to be part of a new star, a new planet, a new form of life. We are part of an endless cycle, a cosmic dance that has been going on since the beginning of time and will continue until the end. And knowing this, we can let go. We can stop clinging to the illusion of permanence, the idea that we can hold on to things forever. We can accept that everything changes, that everything passes, that we are all just temporary visitors in this universe, part of a cycle that is much larger than ourselves. And in that acceptance, there is peace, there is freedom, there is the ability to simply be, without needing to control, without needing to hold on, without needing it to be anything other than what it is. The universe is patient. It takes its time, and in its patience, we can find our own. We can slow down, we can breathe, we can let go of the rush, the hurry, the need to do everything all at once. We can remember that we are part of something vast and ancient and unhurried, something that has been unfolding for billions of years and will continue for billions more. And in that remembrance, we can find peace. And so our long journey through the peaceful universe draws to a quiet close. We have drifted through the silence of space, through the ancient light of stars, through the patient cycles of creation and destruction. We have seen that the universe is not a place of chaos or violence, but a place of balance, of harmony, of slow and steady rhythms that have been playing out for billions of years. We have remembered that we are small, yes, but that we are also connected, made of stardust, part of the great cosmic web that stretches across the universe. We have seen that time is vast, that our lives are brief, but that the matter we are made of is eternal, cycling through endless transformations. The universe asks nothing of us. It does not need us to understand it, to control it, to make sense of it. It simply is. And in being, it offers us a kind of peace, a kind of stillness, a reminder that we too can simply be. We do not need to strive. We do not need to achieve. We can simply exist here and now, breathing softly, resting gently, part of the vast and peaceful cosmos. So now, let the questions drift away like leaves on a gentle stream. There is no need to hold them. The universe will go on turning, stretching, and singing its quiet song. Whether you think of it or not, you can simply rest, knowing you have touched its mystery tonight, knowing you are part of something vast and beautiful and eternal. Thank you for sharing this journey with me. If you have enjoyed it, you can gently like, subscribe, or leave a thought in the comments. It helps others find their way here too. one sleepy soul at a time. But for now, there is nothing more to do. Just allow your body to sink deeper into rest. Let the day fall away behind you. Let the calm widen within you like the open night sky. The universe is vast, and so are you. Sleep well, and I will see you in the next video.